chapter 6 is all about exponents, is what I like to refer to the chapter as. But we're going to work with monomials. So those of you who are really good at like prefixes and suffixes, mono. What does mono refer to? Well, okay, in Spanish it's hand, yes. But like tricycle, tri means 3. Triangle, 3. Anybody with them? Okay. Yeah.
Is it 1?
It's 1. Okay. So a monomial is like one term. So it's either a variable or a number or the product of a variable and number. Okay. So, you know, we've talked about combine like terms before. A term is a monomial. So maybe we have the number 5. Maybe we have something like xy. Maybe we have something like negative 10 x squared y cubed. That would be a monomial. Okay? A monomial is number and or variables multiplied together. Okay? So this is a monomial, this is a monomial, this is a monomial. Okay? Now, if monomials, terms, have the same variable with the same exponents, I've already said this. What do we call those? We have the same variable, like x or x squared.
Are they like terms?
Like terms. Like if you have 3 monomials that are x squared y, then those are like terms. We can add them together. Okay? So if we're going to add or subtract monomials, we have to make sure that they have like terms. If they're like terms, then we can actually do the addition or subtraction depending on what it is. Okay? So like right here, number 1, 17x minus 27x. Are these like terms?
Yes.
They are. So what's 17 minus 25? So this is negative 8x. Okay? Now, we've done that before, but what we're going to do is we're going to spice things up a little bit. Like, look at number 3. Are these two like terms? Yes, it's a little complicated, but they're both a cubed bc. A cubed bc. So since those are the same, we can combine like terms. How many do we have? Negative 9, and we keep the a cubed bc. Okay. How about you do 4, 5, 6, and 8 for me? You do those real quick while I submit attendance. All right, thoughts on number 4. Jace, what'd you write down for number 4?
I wrote 38.
Oh, yeah? Just 38? David? What, do you disagree?
I think so.
What did you put?
I put 37.
Just 37? You didn't put anything with it?
X2Y.
Okay. Jay says 38 x squared y. David says 37 x squared y. Who's right? So when we have like terms, x squared y is what's making them alike, so that stays. What we do is we look at the coefficients and we do the operation of addition or subtraction with the coefficients. So 38 minus 1 is 37. Okay. Are we okay with that? Okay. Joey, what'd you get for number 2?
I didn't do it. It's so bad.
Okay. Are they like terms?
No.
Oh. Well, can we combine them?
No.
No. AB and AC, those aren't alike. Those are that's your answer. You can't do anything with it.
Just don't really understand this.
If you got tricked, yeah.
I don't understand.
That's just your answer.
So you wouldn't put anything? Or would you put that down?
That would be your answer. Okay. Now, Joey, I have a question for you. Are these two the same letters with exponents?
Yes.
Okay, so these have the same variables as this. So they're both mn. Okay? So, what are we going to do with negative 8 and 9?
We're gonna add them.
Okay, what is negative 8 plus 9?
Just mn by itself.
Just mn by itself. If you put 1 mn, that is totally cool. 1 mn is the same as mn. Either way, your answer is right. Okay. Eva, what did you get for number 8? Negative 50, x to the 4th, y to the 3rd. Do you agree? Yeah. We have like terms here, x to the 4th, y cubed. And so we are going to take the coefficients and perform that operation. Okay? Now, what happens when we get to like number 9? We have a couple different things happening, right? Yes? Okay. Are they all 4 like terms? No. So 3y and plus 4y are alike. Plus 9z and minus 3z are alike. So we would combine only like terms. So we could combine 7y and we can combine a positive 6z. So we would have 7y plus 6z. Are you okay with that? Okay. Now, what about when it comes to like number 11? Are all of those 4 like terms? No. They all have w's, but they're not all the same exponents. So I'm okay with 13w squared and plus 4w squared combining, but plus 9w and minus 31w, that's a separate like term. Okay, so we can combine the w squareds to be how many? Thanks for your help. 17 w squared. And then what would I put after that? Minus 22w. Okay. Okay. Now, I do want to talk about number 15. Well, let's talk about like 13 and 15. 13, what does the sum mean?
Addition.
Sum means addition. So if we take 16y squared plus negative 5y squared, what would we get? 11y squared. Okay. Now, if I said difference, it wouldn't be addition, it would be subtraction. What I want you to be careful with, though, is this subtract 9a from negative 15a. Subtraction, the order does matter. So in this one, which term is going to come first in our subtraction? Subtract 9a from negative 15a would mean we have negative 24a. Thank you, sir. Okay. I feel like that's a little bit of a review for most of you from like Advanced Math 7.
No, not for me.
I said most of you. A little bit? Okay. If we have like terms, we can add and subtract them. Okay? Now, here's where I get excited. Page 2. We're going to talk about, okay, product means multiply, right? What if we multiply two terms, two monomials that both have exponents? So I'm just going to give you a scenario, and you're going to help me figure this out. If I have 2 cubed times 2 squared. I want you to think about what that would be. What is 2 cubed?
4. Right? 2 times 2?
2 cubed.
Oh. Hold on. 8.
Okay. This is 8, and what's 2 squared?
4.
So what do we have? Okay. 16 is 2 to what power? Do you know?
4.
Is 8 times 4 16?
I thought you meant 2. I thought you meant 2 times 4. Dude.
32. We're okay. We're okay. All right. So let's think about 32. If 8 times 4 is 32, I mean, that's what this is, right? But what I want two to what power is 32? If 2 to the 5th? Connor thinks. Yes? So let's count on our fingers. 2 times 2 is 4 times 2 times 2 times 2. Okay, so 2 to the 5th power. Do you have an observation?
Yeah.
Let me throw my pen at you, Ella.
You multiplied and you made the 2. But the 2 of them like that.
So the 2 stayed the same. And then this became an addition for the exponents. Is that what you noticed? Okay. Do you think we should try that with another number, or do you think that's going to be true? You want to try it with another number, or no? Yes. Okay. Let's do this. 3 to the first times 3 to the third. Okay, well, what's 3 to the first? And what's 3 to the third?
9. Oh, joking.
27. So what's 27 times 3?
81.
Okay, so let's go back to, we know it's 81. 81 is 3 to what power?
4.
What? Look at that. Okay, here is our product rule. If we are multiplying two monomials and the exponents have the same base, so do you see how these are both x's? So that's the same base. We keep that same base, and whatever our exponents are, we add them together. Okay? Bless you. Okay? So, looking at number 17, if we follow that rule, this would be x to the what? This would be x to the 5th power. Now, let me show you why. What does x squared mean? X squared means x times x, right? Let's go different color. So, x squared means x times x. Times, what does x cubed mean? X times x times x. Well, now, how many x's are we multiplying together? 5. So we have x to the 5th. That's why we do it. Okay. Now, do I want you drawing a picture every time? I don't think that's necessary, but this is why the rule is what it is. Okay. Now, what about this one? A to the 9th times a. I don't see an exponent on the second one. If there's no exponent, we know that it's what?
1.
It's 1. Okay, so Jace, he's excited. A to the what power is our answer?
8 to the 10.
Yes, he says with enthusiasm. Thank you. That's right. Let's go. Okay. All right, so write down what you think the answer is to 19. Hey, Emily, what's our answer? W to the what?
11.
W to the 11. Okay. All right, we could do this all day. Okay. What happens when there's a coefficient on our monomial? Okay. So let's come down here to number 20. We have 4x squared times 3x to the 5th. You guys, 4 times 3 is still 4 times 3. What is that? 12. Okay, so 4 times 3 is still going to give us 12. And then we're going to do our rule for the x squared times x to the 5th. That would be x to the 7th. Okay, do you have a question? No? Okay. Okay. What's going to happen to our coefficients in number 21? Okay, and what would that be? 15. And then we can multiply x squared times x to the 6th to get x to the... Okay. Does 23 scare you? No, it doesn't. Oh, well, that's good. Okay. It shouldn't scare you. Okay. Emily, what are we going to do with -4 and 3?
What kind
To get?
of negative 12?
Okay. Now, I see some A's, I see some B's. Do I squish them all together? No. A cubed times A squared is going to give us A to the, and then we're going to have B to the 6, because this is B to the first. So when we take 1 plus 5, we get that 6. This is too easy. Okay. What I'd like you to do, 24, 25, 27, and 30, and then we'll check back in with each other. Okay? And it's totally cool to check in with your neighbor to see if they're getting the same thing. You guys, it's going to get really cold tomorrow. Yeah, I'm really sad about it. Sunday and Monday are going to be, feels like negative all day. I don't know, but I want this now.
Something that's never gonna get cold. My anger. My God.
All right. Let's talk about these. Aaliyah, what did you get for 24? What did you get for an answer for 24? Do you agree with Aaliyah's answer? No? Is -7 times -4 28? Yeah, positive 28. Oh, it's q to the 9th?
Yeah.
Okay.
It's like a 5. Her little 6 is complicated.
Yeah.
Like it got printed poorly?
Yeah.
I will forgive you. Okay. All right, number 25. Let's see. Camden, what you got?
I got -24x to the 8th power y to the 11th.
Yeah, that sounds pretty good. Do you agree with Camden? Anybody disagree? Don't disagree because he's right. All right, now 27. We get a little crazy here.
Oh, yeah.
Anybody feel confident about their answer for 27? Vivi?
Negative 6a to the 7th and b to the 3rd.
Okay. So we have three things we're multiplying together, but we have coefficients of 1, 6, and -1. So that's how she got the -6. We have a to the first, b to the 5th, a to the 1st, which is how she got a to the 7th. And we have b to the 1st, b to the 1st, b to the 1st, which is how she got b to the 3rd. Do you disagree?
Maybe. I don't know.
Well, it's a yes or no answer. Do you agree or do you disagree?
I don't think I agree.
What do you disagree with?
Wait, no, never mind.
Okay. Glad we got that sorted out. All right. And then number 30. Aubrey, what you got?
80, and then C to the 5th, and D to the 6th.
Good. Okay. Now, what happens when we have multiplication and addition and subtraction in the same problem?
It gets harder.
Okay. It's like maybe we have a rule of some sort for when we have multiple operations in one problem. Oh, PEMDAS. Okay. So if we have multiplication and addition, subtraction, what has to go first? Multiplication. Okay. So we need to do this multiplication and this multiplication before we can do the addition. Okay? So will you do that multiplication for me? Just do these two multiplications. Okay. Rachel, what did you get for your first product?
I got 8x to 6 and y to the 5th.
Okay. Yes, no, maybe?
Yes.
Yes, okay. Great. Tinley, second product.
3x,
No way. Do we have like terms? It's crazy. We have like terms. Since these are alike, we can add these together to be 11 x to the 6th, y to the 5th. Remember, when we add, we have like terms that stay like terms. And we just add or subtract the coefficient. Okay, so for good measure, I'm going to give you 60 seconds to try 36. We're going to talk about it, and then I'll get you going on something else.
It is.
Okay, can you tell me, so do you need a break or do you want to ask me a question?
Just I can't understand because it's like for this one, I don't even know where this one came out of.
So if there's not a number in front of the variable, we know that it's 1. Okay. Do you have another question or do you need it?
No.
Okay. Do you want to try number 36? Okay. But I think everybody's pretty into it, okay? Do you agree with my first step? So then my second step is 18, a to the 4th, b to the 6th. Do you agree there? Okay. Flip over to page 3.
If we just put minus 2 away,
Yeah, that's fine. That's fine.
just